Okay, Sophia Genetics moves precision medicine ahead by our group.
I'm Cindy.
I'm
Andrew.
Gabby,
I'm Adriana.
and I'm Gabby. A new approach to treating diseases, precision medicine, is predicated on the understanding that every patient is unique in terms of their own environment, lifestyle, and genetic composition. Precision medicine has great promise in treating patients with lung cancer, colorectal cancer, and breast cancers, melanomas, and leukemias of any kind. According to current standard of care standards, cancer patients nowadays often receive the same therapy as other cancer patients with the same kind and stage of disease. Gene alterations, which impact how our cells divide and proliferate, are the root cause of cancer. Among these alterations are mutations in the DNA that compromise our genes. Ideally, precision medicine will allow doctors to identify the exact mutations causing a patient's cancer and then prescribe drugs that specifically target and destroy the cells linked to the mutation, as opposed to the current chemotherapy drugs that kill all rapidly reproducing cells, cancerous or not. Patients who get precision medicine therapies that target cancer cells selectively report feeling better, recovering faster, and experiencing fewer adverse effects. Sophia Genetics is an analytics firm established in Switzerland that uses a global network of hospitals and sophisticated AI algorithms to enhance the care of cancer patients. The first step in the process is to obtain the patient's DNA using a biopsy or blood draw. Next, the hospital gets samples ready and uses a DNA sequencer to process them in order to find out the order of the 4 nucleotides or chemical building blocks that make up each individual's DNA molecule. The patient's DNA files are then transferred to the Sophia DDM software as a service platform, where they are subjected to machine learning techniques and patented advanced algorithms for analysis. The software finds genetic variances in the patient and then uses past data to recommend the optimal medicine combinations for treating a particular cancer in a single patient. One of Sophia's DDM's most potent features is its capacity to compare patient data throughout hospitals. This allows its users to inform a patient that out of 1,000 patients, 600 of them receive the required medication and 80% of them live for 5 more years. Hospitals can utilize Sophia DDM as a software as a service platform by accessing it online and paying a nominal cost of $50 to $200 each time they use it to enter a new sample. Within a day, medical practitioners using Sophia DDM for genetic sequencing and analysis can receive suggestions for pharmacological treatments plans for specific patients. In the absence of this technology, choosing a medication course of treatment could take several days. But because precision medicine is still in its early stages of development, it has limitations in terms of cost, accuracy, and efficacy. Not all tumors in people can benefit from it. Tumor cells can differ from person to person based on their location within the body. Even the same tumor from the same patient may differ from one another. Tumor heterogeneity is a major problem in precision medicine that needs to be addressed, along with the emergence of treatment-resistant cells, severe side effects, and expenses. A focus on precision medicine that is too limited could take funds away from other worthwhile directions in cancer research. To fix these problems, time is needed. Recent updates include Sophia Genetics still growing thanks to partnerships with other cancer research institutes around the globe. MIT Tech Review and Fast Company have ranked the company as one of the most inventive in the world. And Sophia Genetics is currently working with 750 institutions across 72 countries. Their network promotes data-driven medicine to enhance global economics and health outcomes. Now, time for Andrew's part.
So bringing up the ethical dilemma, and our broad question is it worth the time and investment within the precision medicine research and development to get it where it needs to be? So aforementioned by my fellow classmate is the opportunity cost. So technically, while there's a lot of funds and timing that go into this specific project, at the same time, we're not going towards that goal right now. So the goal we need to reach for of an automatic globalized database, we're not there right now technically, and it's not perfect. It has some holes in it currently, but with all the time and effort taken on this project, you could easily go to maybe a smaller project and get solutions at a way faster rate. However, there's great potential down the line. There's many other countries who are participating in this. Can change the game for everybody, not just one country as a whole. But the real problem becomes, can we predict it'll be done in a reasonable time? That's something that we won't know until the day it happens. It's going to take a lot of research and development, but it's definitely something that's worthwhile that can change the game for how we know it when it comes to cancer in the medical field and help increase our lives over time. So that brings up critical question number 1. So what advantages does the SOPHiA DDM system have compared to the previous approach by MD Anderson down in Texas? And the better approach that we believe over the long run, currently I would still have to go with the SOPHiA system. The MD Anderson has a greater foundation. They knew exactly what they wanted. They're going for it the whole long way, but I would say they have more funding. They have more collective minds just for one specific goal, but yet they're still failing. And I think that's more of a worry result. They have not got anything close to where they need to be. Meanwhile, SOPHiA, while still not completely perfect, is working toward its goals each and every day, and it's able to actually reach benchmarks and be applicable, while Anderson isn't really being used in a lot of regard. There's a lot more holes, even though it was built for that one specific purpose. And another thing with MD Anderson, the biggest thing, honestly, is that it's not well integrating with other systems. So the SOPHiA system being a globalized database, if you pay that fee, you get into the database, you have the machine learning in the background, the algorithms to make its analysis. It's ideally should be very user friendly. It should be working the way it's supposed to collect and pull all this data and work. But Anderson doesn't really have that sense of collaboration. It's one use, but it's not really integrative as it needs to be. And this brings us to critical question number 2.
The creation of patient database shared among hospitals globally raises concerns about patient privacy. How might SOPHiA DDM address this concern? So the first way they can address this concern is by data encryption. By employing advanced encryption protocols to safeguard patient data during its transmission and storage processes, ensuring that sensitive information remains protected from unauthorized access or interception. And the second way is anonymization by prioritizing the removal of personally identifiable information from genomic datasets, guaranteeing that patient identities remain confidential and data is effectively de-identified. The third way is by the use of access controls, by implementing strict access controls, allowing only authorized healthcare professionals access to the patient data. And the final way is by patient consent, so prioritizing obtaining explicit and informed consent from patients before their data is utilized for research or shared with third parties, respecting their autonomy and right to control the use of their personal information. And for the third critical question,
To research to determine whether or not the SOPHiA DDM technology improved patient outcome, lowered costs, or provided some other benefits. To answer the question 3, I read a story on their website, which I think is really interesting. A family living in Spain had gone through strategies without knowing the reason why. One of their 3 kids died after 43 days being born, and another one died after 20 days. After their second trial of death, the parents decided to perform a test using SOPHiA DMM and the results suggested that both parents had something wrong in their genes, which resulted in their kids' brain disorders and caused their deaths. This helped the family be informed about their potential risks of their future pregnancy. Another information that I found is that till today, there's 1 million genomic profiles being analyzed by SOPHiA Genetics, uh, but there's no information about what is the percentage of that 1 million profiles effectively works. When doing research about how effective SOPHiA Genetics technology is, it's interesting that there's very little information about it. Instead, I see a lot of information about their financial achievements and partnerships with hospitals. This raises questions about the actual impact and accuracy of SOPHiA Genetics technology. While I believe SOPHiA Genetics holds promise in offering potential benefits, it's obvious that there are many areas that they must improve. And that's the end of our presentation.